Alright, let's treat on vector products. Please take note. Now, when we are saying about vector products, is being divided into two. Please take note. When we are saying about vector products, is being divided into two. Now, let's look into the two types. Now, number one, please take note. We have scalar or dot product. Number two, we have cross or vector product. Please take note. Okay, now we are going to treat on this guy here and solve some exam possible questions. And we are going to treat on this guy here and solve some exam possible questions. Please take it. So let's start with this. Please write scalar or dot product. Scalar or dot product. Two vectors A and B. Two vectors A and B is said to be in scalar product or dot product. Two vectors A and B is said to be in scalar or dot product if only if, let's take note, two vectors A and B is said to be in scalar or dot product if only if it is written as A dot B. If only if it is written as A dot B. So whenever you see this expression like this in terms of vectors, it means that that particular product is said to be what? Dot product. Please take it. So let's solve the question here, please. Let's take example one here, please. If B is equal to 2I plus J plus K, and Q is equal to 4I plus J plus K, find P dot Q. Find P dot Q. Now, because of this sign here, it means that this product is said to be dot or scalar product. This thing. So how do we evaluate this guy here? So I have this to be P dot Q here. But before I evaluate this guy here, there's what you have to know in terms of dot product. What is that? Just know that whenever you have this, whenever you have I dot I or J dot J or K dot K, at this point is said to be 1. This thing. Whenever you have I dot I or J dot J or K dot K, what does it mean here? It means that whenever you dot the same vector, the result is said to be 1. But whenever you dot different vectors, the result is said to be 0. This statement. So if I have I dot J and if I have J dot K, please take note. And if I have I dot K, the result is equal to 0. Please take note. So this is what you guys have to know before we evaluate anything about dot products. Please take note. So if I dot I is equal to J dot J is equal to K dot K equal to 1, it means that this guy is equal to 1 or this equal to 1 or this equal to 1. Please take note. So let's solve on this guy here. I have this to be P dot Q. So I'll replace this one after the other here. Please take note. Okay, now I'll replace this one after the other here. I have P dot Q. This will be equal to plus. What is my P here? 2I plus J plus K dot. What is my Q here, please? 4I plus J plus what? K. Please take note. So whenever we want to simplify any dot product here, we always simplify this according to the corresponding vector. Please take note. So if I have something like this, if I have A plus B into C plus D, just like the expansion, you will time this guy with this, you will time this with this. That means you are done with your A. So the same thing here, you will time this with this and time it with this. But in terms of this guy here, I will times this with the corresponding vector here. So this corresponds to this guy here, and this corresponds to this guy, and this to this guy here. So when you do this will be equal to plus the number will times itself. But when you are representing the vector, it's going to be on dot method, this statement. So this will be 2 times 8, so 2 times 4 will give us 8, this statement. In terms of vector here, it's going to be I dot I. This will be I dot I, this statement. So there's an invisible one here. This will be 1 times 1 here, this statement. I will have plus 1. But in terms of the vector here, it's going to be j dot j. This will be j dot j, this statement. Plus, let's find the numbers first. The number that we found here will be 1, the same thing here, 1. So this will be 1 here. But in terms of the vector there, it's going to be k dot k. But remember here that I dot I is the same thing as 1. J dot j is the same as 1. The same thing here. K dot k is what? 1. When you replace the values here, this will give us 1. This will give us 1. This will give us 1. So the answer to this will be 8 plus 1 plus 1. What is the total answer to this one here? 10. This statement. So my answer here is set to be 10. Okay? Now let's solve some question in terms of magnitude and absolute value. This statement. Let's solve some question on magnitude and absolute value before we solve some question on angles relating to the scalar products. Okay? We have considered some questions on scalar or dot products. Now let's consider a question on magnitude, because without magnitude we can't solve or calculate any question on angle relating to dot product. This so let's know how to calculate magnitude. Now, when I want to calculate magnitude here, magnitude is the same thing as absolute value, this statement, or is the same as modulus, this statement. Magnitude is the same as absolute value or modulus. So whenever they say about magnitude, what should come into your mind is what? Application of Pythagoras theorem, this statement. So if I have something like this, maybe I have a sketch like this statement. I have a sketch like this. And this my theta here, this my d, this part here is y, this part here is s. This is for 2 dimensions. So if I have this here and I'm asked to find the magnitude of d, so it means that we apply Pythagoras theorem here. What does it say here? Is that the square of the hypotenuse is the sum of the 2 squares in a right angle triangle, this statement of this. So I'm going to square this, and this will be d squared will be equal to s squared plus what? Y squared. So making d the sum here, this will be square root of s squared plus what? Y squared. But this is not magnitude because we have not assigned the main sign here. What is the main sign here? So the sign for magnitude is 2 strokes here will be equal to that square root of s squared plus what? Y squared. This is magnitude for 2 dimensions. So solving this in 3 dimensions, that is for I, J, K, that means I'm going to include Z, this table. So this is for 2 dimensions, that is for only I, J. So what is magnitude for 3 dimensions here? Now in terms of 3 dimensions here, so express our magnitude will be D almost 2 strokes will equal to square root of S squared plus what? Y squared plus what? Z squared. So and I told you guys that S is the same as I, Y is the same as what? J, Z is the same as what? K. Please take it. So to calculate the magnitude of this guy here, it means that our I here is 7, our J here is -3, our K here is what? 2. Please take it. So let's calculate the magnitude of this guy here, please. Now calculating for the magnitude here, I'm going to have my expression to be this. I'll use it because it's said to be in 3 dimensions. That is I, J, and K. Magnitude of this, that means the magnitude here will equal to square root of S squared plus Y squared plus this is the nearest one is 49, right? 49 is 7, so 62 will be 7.9. It's too short.
That should be the answer.
Because 49 is 7, so
It can't be 3.9, it can't be 2.9.
yes. Okay, let's go. So I'm done with this. Let me just solve some exam solution for the rest. Alright, let's solve an exam possible question here in terms of vector. So if you look right here, we have a dot product question here. We have an arrow here. So we are going to look into these two questions here. So we are giving A to be 6I plus J plus 2K and B to be minus I plus 3J. We are asked to find the dot product of A and B. And I told you guys that whenever we are asked to find dot product here, it simply means that if I have A and B, the dot product will be A dot B, this statement. So you can either call it dot product or scalar product, this statement. So I'm going to replace our A here. The A here is said to be 6I plus J, this statement, plus 2K dot. Our B here is said to be minus I plus what? 3J. So evaluating this guy here, I'm going to evaluate this according to the corresponding vector-based statement. So this is going to be, this is 6. There's an invisible one here that is minus 1. So 6 minus 1 is the answer, minus 6. But multiplying this vector here, I'm going to multiply this in terms of dots. This will be I dot I. This is going to be I dot I. So in terms of J here, there is 1 here. I will multiply the number together, but in terms of the vector, I will dot the vectors. So this is going to be plus, please take note, 1 plus times 3. What is the answer? 3. The vector will be J dot J. This will be plus 2 times. So if you look right here, this K here is not here. So and I told you guys that whenever the vector is not actually present there, it means automatically the vector is what? 0, please take it. So it means that there is plus 0 K here, please take it. So at that point here, 2 times 0, what is the answer here, please take note. 2 times 0 here will be what? 0. That is the vector will be what? K dot K. And I told you guys that in vector I dot I is equal to J dot J is equal to K dot K is equal to 1. So anywhere you see I dot I, you replace as your 1. Anywhere you see J dot J, you replace 1, and this one here is equal to 1. So we place our 1 here, A dot B equal to minus 6 into 1 plus 3 into 1 plus 0 into 1. So totally here, our answer is said to be minus 6 plus 3. Please take it. And the result is going to be what? Minus 3. So this is how we solve any dot product here. So let's try to solve a particular question that involves an angle. Please take it. So when we are asked to find the angle of any dot product, how do we find that angle? And sometimes you give a question and the product might not be known to you. So whenever the product is unknown to us there, we always use dot product. Why? Because dot product is always rampant compared to vector product. Listen, if the product is unknown to us here, and we are asked to find the angle of that vector, so we use dot product. Please take it. So let's try to solve the next question here, please. The formula to solve for the angle of two vectors in 3 dimensions. So the formula is said to be this. I'm going to allow this to be A magnitude B magnitude cos theta is equal to A dot B. So making cos theta the subject, this will be cos theta will be equal to A dot B divided by A magnitude, what again? B magnitude. So if the two vectors are said to be A and B, I'm going to use A and B here. If the two vectors are said to be D and E, I'm going to use D, E here, these labels, depending on the letters. So therefore, it means that calculating for that question here, our cos theta, this is the formula to use in finding any angle in terms of these labels. So now to find this particular question here, since it's a basic question here, our cos theta is going to be equal to A, capital theta A, because we are giving capital theta A here, please take note, dot capital theta B, all divided by A magnitude B magnitude. So we know what dot is, we know what magnitude is. We have to solve this one after the other here. So we have found the value for A dot B. A dot B here, please take note, gave us -3. So let's find A magnitude here. And I told you guys that magnitude is the same as absolute value. It is same as modulus. So altogether, it is same as what? Application of Pythagoras theorem. So finding this guy here, our A magnitude is said to be square root of. Let's check what the vector is. If it's in 3 dimensions, we use the 3-dimension formula, that is S squared. This takes plus what? Y squared plus what? Z squared. So our A magnitude here will be equal to square root of, what is our S? S is the same as what? R. So this will be 6 all squared plus, what is our Y here? There is an invisible one here, please take note. We only take the values here. That is 1 all squared plus, what is our Z here? That is 2 all squared. So our A magnitude here will be equal to square root of 36 plus 1 plus what? 4. So altogether here, the answer here is said to be 41. Please take note. So our A magnitude here is said to be square root of 41. So let's send this in decimal point. Square root of 41 is going to be
6.4.
6.4. Please let's approximate this to 4 decimal places because we are going to use the value to solve for a particular stuff here. Whenever we are solving a particular question and it comes into decimal point, we always approximate that to 4 decimal places. That is the reason for our 4 figure table. So to get the right answer here for theta, since I'm going to use this guy here to solve for theta, that means I'm going to approximate this guy here to what? 4 decimal places. So approximating this to 4 decimal places, what is the value of this?
6.4031.
6.4031. Please take it. So we have known our A magnitude. Please take it. The next thing here is to find for B magnitude. Please take note of this. B magnitude here. So our B magnitude, please take note, we said to be square root of. First of all, let's know the dimension. How many dimensions is said to be 2, right? So this is going to be, and it's said to be S and Y, right? So this will be S squared plus what? Y squared, because we only have I and J. Please take it. So class, what is our I there, please class? -1. Look what the question says. There is -1 there. Please take it. This will be -1 all squared plus 3 all squared. So our B magnitude, please take note, is said to be square root of 1 plus 9. What is the answer at this point? Square root of what? 10. So let's approximate this here to decimal point. What is decimal point here, please? So this is going to be 3 point what?
1623.
1623. Please take it. We all know the reason why we are approximating this to 4 decimal place. Please take note of this. So at this point here, we know our A dot B. Please take note. We know our A magnitude. We know our B magnitude. That means I can now replace into this and make theta the subject of formula. Doing this here, I'm going to get this to be cos theta here to be equal to -3 divided by
52.
98.52
226.
226 like this.
Yes.
Now I was doing this guy here in the whole number, that's the nearest degree here, this will equal to 99 degree base of this. Alright? Now you can subscribe to the channel to get more of our video on vector or cross products and also some of the examples of questions on it. Thank you so much.